All right, we're going to look at exit slip 3.3 here. The I can statement with this in this lesson is to use the U.S. traditional algorithm to solve different decimal problems here. So we want to use the traditional way to solve here. So we've got some adding and subtracting we're going to be doing here in the traditional way in this lesson. Okay, so 1A here, we're going to take 4 and 7/10 plus 18 plus 21 and 63/100. And guys, always a good idea to estimate just so when I get an answer I know if it makes sense or not. And in this example, if I'm going to do some quick estimating, and it can look a little different, but I want to do it as easy as possible. So I'd probably 21 is close to 20, 18 is close to 20, so I'll go ahead and use that, and 4.7 really close to 5. So I can look at that and say 20 plus 5 is about 45. So if my answer comes up around 45, most likely I've probably done it correctly unless I messed up a fact here. So we're going to go ahead and look at the real answer here. And remember, in the traditional system here, guys, we're going to line up that decimal. It doesn't matter what order I put these in because of the commutative property, but I think I'll just start with 21.63 here. And the problem some people run into, they're not sure where to put the 18. 18 is actually 18.00 because there's no tenths and no hundredths, so then it's actually worth 18. Some people put the 18 over here sometimes, and that's actually 1800ths, and my answer doesn't make any sense. And then 4 and 7/10, here's my ones column, so 4 and 7/10, and then I know I can put in a 0 there because it's still 7/10. There's 0 hundredths, so it doesn't change the value. And then all of my place value columns are lined up, and my answer will make sense. And we always start on this side. And again, you could be, if you get real technical, you could be thinking this is 3 hundredths plus no hundredths plus no hundredths. It's actually 3 hundredths. It's not 3 because I'm in that hundredths column. And this is 7/10 plus 6/10 gives me 13/10, but I can carry over and we say we compose a unit of higher value. So remember, it's 13 we would say, but we carry the 1 or compose a unit of higher value because 10 of those makes one of these. So if this is actually 10 of these and 3 is that 13 that we had there. Now we're in my ones column. So 8 plus 4 is 12, 13, 14. That's 14, and I carry my 1 or compose a unit of higher value. And I'm going to put my decimal here. Forgot that decimal goes straight down there, so it keeps my place value columns where they should be. And I know this is 2 plus 1 is 4. And we should know actually it's 40 because we're in the tens column. So when I get done, I get 44 and 33/100. And I look, my estimate's around 45. It's really close to that, so my answer makes sense. I probably had the decimals lined up correctly. Because if I didn't, my answer would come up maybe way off from 45, and I know it didn't make sense, and I probably messed it up somewhere. So don't forget that estimate step here. Okay, doing a little subtraction here. Again, just because the answer's on this side, it doesn't mean we go this way. We always read it left to right, guys. This is 9, take away 6 and 37/100. We're just putting the answer on the other side. So again, we put 9 sometimes. Well, first of all, let's estimate. 6.37, still pretty close to 6. So I could be thinking 9 minus 6. My answer should be close to around 3. All right. Sometimes people put this on top when they go to do their work too because it looks, larger because there's more digits in it. But guys, we have to write the 9 first. But the 9, guys, we should write as 9.00 because I know this one's going out to the hundredths too. Again, that's still 9, hasn't changed any value. So I'm going to take away 6 and 37/100. Sometimes when people make mistakes on this, they just put a 3 and a 7 down here. Okay, and we cannot do that. Okay, 0 minus 7 is not 7, it's -7. So that doesn't make mathematical sense. It'll be off if we do that. And 0, we can't borrow here. We say decompose from a unit of higher value. That's just nothing to borrow from over here, decompose. So if I go over here, I can borrow or decompose one of these. If I take one of those away, remember this column, it gives you 10 of these. So you just put a 1 there, and that makes it 10. Okay, but now I've got to decompose again because I can't do 0 minus 7. So if I take 1 away here, that gives me 10 of these. And now I'm able to subtract in the traditional way. Okay, so 10 minus 7 is 3. 9 minus 3 is 6. Decimal stays put, so I'm in the right column. Still a tenths and the hundredths. And then 8 minus 6 is 2. So I end up with 2 and 63/100, which again is very close to 3. So I probably did it correctly. Okay, unless you would mess up a fact somewhere in there Again, that's that traditional way of, we used to call it borrowing, but now we say decompose units of higher value. And every time you take one away, you know that gives you 10 of the other column, because all the columns are 10 times different in size than the column beside it. Okay? All right, so I'll pause the video if you guys haven't got this written down. We'll make sure we have it written, and we'll move down here to number 2. So keep on writing these. And again, I'll pause the video if needed here for a second. All right, moving on to number 2 and 3. Again, we got a little word problems going along with it this time, if we can decide what to do. So a lot of times you got to read carefully and see what it's asking us to do. I'm going to add, subtract, multiply, divide. What am I going to do? So we got to have some understanding, be a good reader. It says a rectangular garden is 6 35 yards wide and 8 27 yards long. How much fencing will it take to enclose the garden? How much fencing do I need to enclose it? Now I know when it says enclose, that means I'm going to put a fence around it. Okay, so I'm going to try and draw a picture. That usually helps me here. Try to picture the situation a little bit more. So if I made a quick rectangle up here, because it's a rectangular garden, and I'm going to make the longer one 8.27 and the shorter side 6.35. All right, so I'm trying to enclose it. How much fence do I need around it? So my brain tells me, guys, I could add them all up to get that. This is not an area problem. This is not trying to find how much area there is in here. I'm not taking length times width. And that's what a lot of kids do on this sometimes. I should know in a rectangle, the opposite side is congruent. It's the same, so that's also 8.27, and this would be 6.35. So you have a couple of different options for your number model on how to find your perimeter in this case. Perimeter is the distance around. So I could just add them all up. So I could take 8.27 plus 8.27 plus 6.35 plus 6.35. All right, and I can write those in any order because of the commutative property. But a lot of times you'll see when people do this, they'll use a little multiplication. They'll say, well, it's 8.27. There's 2 sides, so I take that times 2. I'm going to put that in parentheses because that represents both these sides. Plus, I'm going to add that to these 2 sides, and I can write that as 6.35 times 2. Again, we can use those parentheses, which means to keep them together and do that first. So that just is doubling each side, and then I could add them together. So in my solution, I could pick either a strategy that I want to do that. And today, we'll just do the quick adding since we've been focusing on that, and we're going to get to multiplication and division later. So again, I'll pause if you need to. We can write both of these. Either one would work. Okay, and in this time, I'm not going to go through and show the whole process. Okay, we did that on the first 2 problems that we talked about. But when we add all these up, we're going to get, I'll just make sure we have the right answer in here, and you guys can be adding them up, trying to get this and helping each other if we need to. But when you get done, guys, you'll get 29.24. And how much fencing will it take? We're in yards. You want to remember to get that label in there. So 29.24 yards of fencing. So in this case, if you go into the store, right, you want to make sure you can buy the right amount of fencing. You don't want to have too little and have to go back or buy way too much and spend too much money. So you want to be able to figure out how much fencing you'll need. And that's one example there how you could do that. Okay. Number 3, same thing. We're going to go through the process and let you guys work on the adding and subtracting and things we have to do to solve it. All right, so in this case, Tiana earns $1,978.37 per month. How much money does she have left after paying all of these bills? She's got to pay her rent. Groceries is $299.87. The rent was $850, and electricity is $78.57. All right, so we need a number model of kind of how I can attack and solve this. So there's different ways to be thinking about this. You know, if this is your total money, you could subtract one thing at a time and just keep subtracting. I'm probably going to add up all the bills first. So my number model will look like this, and you guys can put it down here, but I'm going to write it up in here. Let's figure out her total bills and how much she has. So I'd have to take $850 and add $299.87 and $78.57. And just like the examples we did up above, you got to line up that decimal, keep that place value column lined up. Okay, and if I do that, again, estimating in my head, this is about 900 and 300, that's 1,200, another 100. It might be about 1,300, 1,200, somewhere in there. When we add all these up, and again, we're not going to go through the whole process right now. We'll let you guys practice that here in a second and make sure you get the right answer. But if you add all this up, you're going to get $1,228 and 44 cents. All right, so that's how much you have in bills. Okay, so we're not done yet. We need to figure out, we want to know how much money does she have left. So once I have this figured now, I can take $1,978.37, and I'm going to subtract out, move this over a little bit, or I'll just do it up here, $1,978.37, and we're going to take away our total bills, $1,228.44. Okay, when I subtract those by decomposing units of higher value when I need to, you should come up with an answer of $749. And again, I'm not going to do the work here just for time's sake, but you're going to get $749.93 is the answer that we're looking for here. So you guys can practice and make sure you get that when you're getting these lined up and written here. I'm going to finish with the number model, though, is how you could see this look. To start out, it could be this. Okay, we can use some parentheses. We can say we're going to take the $1,978.37, which is how much money she makes per month, and we're going to subtract, and we're going to put it in parentheses, and we're going to subtract $850 plus $299.87 plus $78.57. Okay, and I think we can see that on the video camera. I wrote kind of small there, but really, you might see the problem written like this. It's $1,978.37, and take away the quantity of this, we would say. All of this added together, which is what we did up here. And you may see the problem written like this, which means to do this first, and then you subtract after you get that done. And you should come up with this dollar amount left, okay, to pay for other things that might prop up during that month. All right, make sure you get these written down.